This might be as close as we ever get to an actual photograph of a single atom of hydrogen. Hydrogen is an almost ideal fuel source. It has high energy per unit mass, it burns cleanly, and there's an inexhaustible supply. Welcome to Need to Know, where we break down key technologies, engineering fundamentals, and the latest breakthroughs shaping science and innovation. My name is Matt, and here's what you need to know about using hydrogen as a fuel. Hydrogen is an excellent fuel, but there are challenges to producing, storing, and using it. It's the most abundant element in the universe, but it's not freely available. It's almost always bonded to something else. Hydrogen and oxygen in the form of water is the most recognizable example. Almost all industrial hydrogen is produced by separating water molecules into hydrogen and oxygen. The classic process for doing this is called steam methane reforming. In SMR, methane, usually from natural gas, is mixed with high-temperature steam and a nickel catalyst to produce carbon monoxide and hydrogen. The process is efficient and low cost, but it relies on fossil fuels and emits significant amounts of carbon dioxide. So the goal is to develop a green production method. There are many possibilities, but by far the most promising right now is electrolysis. Electrolysis requires an anode, a cathode, and an electrolyte, usually a membrane or some other type of separator, immersed in water. Applying an electric current initiates an electrochemical process that separates water molecules into hydrogen and oxygen. If the electricity comes from a renewable source, then the production process is considered completely zero emission. There are several companies around the world racing to design factories that can produce hydrogen cost-effectively at industrial scale using electrolysis. So what do you do with hydrogen once you've produced it? The most well-known use of hydrogen involves burning it directly. Liquid hydrogen is an excellent rocket fuel because, per unit mass, hydrogen has nearly 3 times the energy content of gasoline. This is why steel mills around the world are beginning to experiment with burning hydrogen instead of coal or other fossil fuels in their efforts to reduce their carbon footprints. But for most industrial uses, the hydrogen we produce is stored for subsequent use. When stored hydrogen is reintroduced to oxygen, the two not only combine back into water, the process produces an electric current. This is running electrolysis in reverse, essentially how hydrogen fuel cells work. Hydrogen fuel cells are being used in a number of applications, including fuel cell electric vehicles. Early FCEVs include cars, light airplanes, forklifts, and small watercraft. Designing systems with fuel cells will of course be different than designing systems with internal combustion engines or batteries. For example, fuel cells create a low voltage, high current output, so it'll almost certainly be necessary to use DC to DC boost converters to step up output voltages. And that's just one example. Another thing, yes, hydrogen carries more energy per unit mass than gasoline. On a volume basis, however, the situation is reversed. Gasoline has 4 times the energy density of liquid hydrogen. As a practical matter, this means that hydrogen will almost always have to be compressed when stored. Engineers will always have to balance the power requirements of the application against storage space and compression levels. Another proposed use for hydrogen is as an energy storage system. Here's the idea. Solar and wind are intermittent, and that's a perpetual challenge for managing the grid. The idea is to use excess power from solar and wind farms to make hydrogen. The hydrogen can then be used for any purpose, including being converted back into electricity, and this can smooth out fluctuations in solar and wind power for when the sun is down or the wind isn't blowing. And that's what you need to know about hydrogen as a fuel source. To learn more, check out this article on our website. You're also welcome to browse our technical content library with articles on a very wide range of subjects. And don't forget to subscribe to our YouTube channel to keep up with what you need to know.